Hey guys, welcome back. We're going to do the back. The standard test score of 16 students have a mean of 200 and a standard deviation of 20. What is a standard error? Okay, well, number 6, our standard error would be s sub x over the square root of n. And we know the standard deviation is 20 and that n is 16. So we have 20 over 4. So we get 5. That's our answer. Good times. What about 6? A newspaper conducted a statewide survey concerning 2008 racers. Question 7 states the newspaper took a random sample, assume SRS, of 1,200 registered voters and found that 620 of the 1,200 would vote for Republican. Let P represent the proportion of voters that would vote Republican. A 90% confidence interval is done. Awesome. So let's use our calculator. We go to menu, stats, confidence interval. We go to 1 proportion Z. And what was success? 620 said yes out of 1,200. We are going to move the confidence level down to 90. So very carefully make sure we put the confidence level at 90 and we're going to hit enter. Bada boom, bada bing. The p hat is 0.516, rounded up to 517, but all the choices say that. The margin of error is right here. Margin of error plus or minus 0.024. Margin of error 0.024. So the calculator did it all. The calculator did the entire problem start to finish. Okay, the calculator is your friend. 8. After a college football game, football team once again lost a football game to the college arch rival. The Alumni Association decided to get a survey to see if the alumni were in favor of firing the coach. Let P represent the proportion of all living alumni who favor the firing. Which of the following is the smallest sample size needed to guarantee that an estimate is within that? So that's what they mean by within. They're saying the margin of error we would like would be plus or minus 5%. They want to do a 95% confidence interval, right? So no bigs. They want to know what's in. So this is a proportion question and 95 confidence intervals. So we need our formula Z star times our standard deviation. So that's just the square root of P times 1 minus P over N. Z star equals P, square root of P times, yeah. Cool. And that one I have memorized. That's 1.96. And what's my proportion? I don't know. They didn't even say. That's so rude. So you assume 0.5 unless they tell you otherwise. You assume complete indifference. I don't know. Half people said, yeah, fire him. Half the people said, no, don't. And so here we go. So this is equal to our margin of error, right? This is our margin of error formula. And we know that they want the margin of error to be 0.05. Okay, so let's do it. Usually what we need to do is divide by, throw that pen away, divide by our Z star. Okay, and that goes away. So let's do that part first. 0.05 divided by 1.96. Okay. Beautiful. 0.5 times 0.5. We can do that little part over n. Okay, so this is what we have here. Now we're going to square both sides because we don't like the looks of this stuff. We need to get rid of that. So now we have this and we have that. And we'd like to swap spots with these so that n is by itself on one side in the numerator position. So n is up here. And this is down here. Okay, so that's what n is. Let's see what happens. So we get 0.25 divided by parentheses 0.02551 parentheses squared. Bam! 384.166. 384.166. So let's take a look here. We can't have a percent of a person, so we would have to round up to 385. That is our answer. Awesome. Okay, let's look at number 9. An SRS of 100 people, postal people, in fact, found that the average of these employees working of service was X bar is 7 years with a standard deviation is 2 years. This is called them giving your summary statistics. They're giving you the statistics here. Assume the distribution in time and pop has worked for postal service is approximately normal. A 95% confidence interval for the mean mu population of postal service has spent is what? Let's make the calculator do everything. The calculator is going to do all the work. Let's make it work. Okay, so we go to stat. We're going to do confidence interval. We're going to not do a proportion. We are going to do a t interval. And we don't have the raw data. We have the stats. Okay, this will be fun. So X bar is 7 years. S sub X is 2 years. N is we talked to 100 people. And it's a 95% confidence interval. Bada boom, bada bing. Make the calculator do everything. So X bar is 7 and the margin of error is 0.4. They just did everything. This is the X bar plus or margin minus the margin of error. So we got 7 plus or minus. That's what our calculator said. And they rounded it for us, okay? Awesome, I love the calculator. The calculator's your friend. Okay, that was 9. Let's do 10. So much fun. Okay, I love this question. So awesome. Do students tend to improve their SAT math scores the second time they take the test? A random sample of 4 students who took the test twice earned the following scores. Okay, so assume that they change the SAT math score, second score minus first score. Okay, so that's actually our true data point. So this question is really just a one sample, but they asked you to do a little math ahead of time. So I call that pre-math. Do a little pre-math. Before you do math, do a little math. Okay, so I need to find the data, the real data they've asked me to figure out for student 1. So for student 1, second score minus the first score is -10. Okay, right? Second score minus first score. For student number 2, I get second minus first, I get 80. Second minus first, I get Zippo. Second minus first, I get 30. So this is really the data we want because this would tell us, please tell me with 90% confidence the true average of improvement, right? We're really trying to see, we're trying to gauge improvement. And so that's really what we call in science, we want to know the delta. Okay, so I have raw data. So if I have raw data, I need a chart. So I'm going to go to chart. Yeah, I don't know. These are SAT scores. So SAT score. Okay, SAT scores. So my first person score dropped 10. The next went up 80. The next was no change. The next went up 30 points. Okay, now my data's in. So I'm going to make my calculator do a confidence interval. So let's make him do a confidence interval. Okay, so we have data here. We actually typed in, and we only have 4 data points. So this is definitely a T. So we have data. Okay, we got data. What am I going to call this? Stat score. And I just have to make sure, am I supposed to do a 95? No, I'm supposed to do a 90. Okay, so 0.90. All right, going to hit enter. Going to force it to do my dirty work. X bar and margin of error, 25 and 47.555. So I get 25 plus or minus 47.555. Looky there. The calculator did everything. Way cool, right? Now, what if you wanted your calculator to do more? You know what? It could. It totally could. So let's say I want a new screen. Could I have done the math in here? Yeah, I could. I could have put this is getting tricky, but I could have put equals 440 minus 450, enter, and it would have gotten -10. I could have used each cell as a little mini calculator, 600, but I have to use the equal sign so it knows I want it to calculate. 600 minus 520, enter. 720, oh, don't forget your equal. 720 minus 720, enter. Equal 630 minus 630 minus 600, enter. Okay, so there's my data points. Now don't forget, you still have to name them. Bada boom, bada bing, you're still gonna get the same data, okay? Make sense? Check out the next video to keep fixing your test.